Lesson 34 is about the greatest common factor. And Lesson 33 we learned about prime factors. Now the greatest common factor, just think about what that's saying there. The greatest, that would be the largest. Common, that means that you're comparing some different numbers or terms and you want to see what they have in common, what the greatest factor that they have in common is. For example, if you had these two numbers, 20 and 60, they both have a 20 in common. That would be the greatest common factor, because in 60, 20 times 3 is equal to 60. 20 is a factor of 60. So the greatest common factor that they both have would be 20. This can be applied to problems that contain variables as well, like if you had these two terms, 3x cubed and x squared y. Now what you would do here is you look and see what numerical factors they both have in common, what the greatest common numerical factor is. Then you look at the literal or letters, variables if you want to call them. There's different names you can give them. Variables, letters, unknowns. Let's look at the numbers first. We have a 3 in the 3x cubed and then an x squared y. We can just think of that as 1x squared y. So the common factor, the greatest common factor that they have there in terms of numbers would just be a 1. So we don't need to write anything down. Now let's look at the x's. There's an x cubed and an x squared. So we know that there is at least an x that they have in common. And the greatest common factor would be x squared, because they both have at least x squared. That's what you have to look for in the variables, is what do they at least have here? X by itself would not be the greatest common factor. X squared would be the greatest common factor. X cubed would not be the greatest common factor, even though it's the largest power or the highest power. They both have to at least have x cubed for x cubed to be the greatest common factor. X cubed, that can be broken up into x times x squared, right? So that shows us that they both have x squared in common at least. And so that's the greatest common factor there. And then the one on the left, the 3x cubed, it does not have a y term in it. The one on the right does. They both have to have that variable in common in order for it to be a greatest common factor. So we can't use y, and so the answer there would just be an x squared. That's the greatest common factor between those two terms. So try to remember what I've written there in red. The greatest common factor, what that is prime factors that are common to every term, each to the highest power that it occurs in all of the terms. It has to occur in all the terms. Let's do a practice problem. We have 3 terms there in that problem, and we want to find the greatest common factor between those terms. Now when we have an expression like this, we don't worry about the minus signs when we're trying to figure out the greatest common factor. We just look at the numbers, the absolute value of them, and we ignore the minus signs in between. So first, let's look at the numbers, the 8, the 4, and the 12, and let's think about what the greatest common factor is between those 3 numbers, and that would be a 4. They all have at least a 4 in common. That would be the greatest common factor. They all have a 2 in common as well, right? But the greatest common factor would be a 4. Now let's just go through the variables, variable by variable. Let's start with the a's. And in the one on the left, the term on the left, we have an a squared. Then the middle term, we have an a cubed. And the one on the right, we have another a squared. So the greatest common factor that they all have in common would be a squared. It wouldn't be a, because they all have an a. The greatest common factor would be a squared. And then let's look at the b's. The one on the left has a b, or b to the 1. Then we have a b squared and another b squared. So they all have at least a b in them, and then b to the 1 is the greatest common factor. So we just put a b here. Now let's look at the c's. We have a c to the 3rd, a c to the 4th, and a c squared. Now they all have a c in them, so we can write down c, but we wouldn't just leave it c to the 1, because the greatest common factor, the one that they have all in common, that's the greatest, would be c squared. They all have at least c squared. So there's our greatest common factor between those three terms: 4a squared b c squared. Look at practice problem B. We have three terms again. We want to find the greatest common factor between these three terms. Let's look at their numbers that they have for coefficients first, the 9, the 12, and the 3. And we see that they all have at least a 3 in common. And that would be the greatest common factor as well. So we write down a 3 for the coefficient. Then let's look at the x's. We have x to the 8, x to the 4, x to the 3rd. So they all have an x, and the greatest common factor there would be x to the 3rd. They all have at least x to the 3rd. Now the y's, let's go to that. They all have a y in them, and the greatest common factor for y, that would be y to the 5th. And then the z's, they all have at least a z in common as well, and the greatest common factor there for z would be z to the 3rd, because they all have at least that. That would be the greatest common factor. Not just z, but z to the 3rd. So there's our answer there. 3x cubed, y to the 5th, z cubed. Let's do one more. We have two terms in this problem, and let's just go ahead and look at the numerical parts first and find the greatest common factor there. So we have a 42 and a 16, so that's two even numbers, so we know that they at least have a 2 in common, but we want the greatest common factor. So they both have a 4 in common, right? Because you'd have 4 times 13, and 4 times 4 is 16. So that's the greatest common factor, is a 4 in terms of the numerical coefficient. Now let's look at the m's. We have an m on the left there, m to the 8th, and on the right, kind of need to look for it. It's not the first one. It's the second variable there, m to the 7th. So they both have at least an m to the 7th. So that would be the greatest common factor. Now let's look at the n's, and they both have an n in them, and they have an n to the 6th in common. That would be the greatest common factor. Then the p's, they both have a p in them, and p to the 6th and p to the 3rd, so p to the 3rd, that would be the greatest common factor. And then lastly, the x's, they both have an x in them, and there's an x to the 9th and an x to the 5th, so x to the 5th would be the greatest common factor there. We don't just write an x down, we write x to the 5th, because that would be the largest or greatest common factor. Hopefully you noticed the error in this problem. The numerical factor, the greatest common numerical factor, is not a 4, it's a 2. I had said that 4 times 13 is 42. That's not right. 4 times 13 is 52. So the greatest common numerical factor there is a 2 between the 42 and the 16. So greatest common factors, those are prime factors that are common to every term, each to the highest power that it occurs in all of the terms. So when you're dealing with the variables and their powers, each term has to at least have that power to be considered a greatest common factor. Okay, well that's all for lesson 34.